Hello children. Now before we start a new chapter, we will see one topic and the topic's name is factorial. Okay. So factorial notation, let n be a positive integer. So let us consider any positive integer. Okay. That means 0, 1, 2, 3, 4 like that. Okay. Then the continued product of first n natural numbers is called factorial n, to be denoted by n, and this is exclamation mark. Okay, or you can see it's something like L. Okay, and this n is written over here. Okay, so either you write this n and then exclamation mark, or you can write this way. It means factorial n. Okay, and we also denote factorial 0 is equal to 1. Okay, when n is negative or a fraction, factorial n is not defined. So you should know that factorial is only defined for positive integer. That means 0, 1, 2, 3, 4, so on. Okay, not for negative, not for fraction. So thus if it's written factorial n, okay, that means n into n minus 1 into n minus 2 into dash 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 3 into 2 into 1. Okay, so for example, you can see over here factorial 6 means 6 into 5 into 4 into 3 into 2 into 1, whatever you get. Factorial 3 means 3 into 2 into 1 equal to 6. Factorial 1 means 1. Okay, factorial 0 is also 1. Okay. If you have got calculator, then if you have got a bigger number, then you can use calculator. Okay, like here you can see if I want factorial 6. Okay, so I'll press 6 first, then I'll press shift, then this factorial is equal to 720. You can see 720. Yes, so you should have one scientific calculator with you. Okay, next, deduction. Factorial n. So like here factorial n means n into n minus 1. Like here if I write factorial 3 means what? 3 into 3 minus 1 into 3 minus 2, so on. Yes, so same way if I write factorial n, that means equal to n into n minus 1 into n minus 2 into n minus 3 dash 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 into 3 into 2 into 1. Okay, so equal to n, and now this whatever we have after n, we can put this in bracket. Done. Okay, so if you see this from n minus 1 n into n minus 2 n minus 3 dash dash 3, this is nothing but this is n minus 1 factorial. Yes or no? This is nothing but n minus 1 factorial. So n factorial can be written as n into n minus 1 factorial. Yes. So for example, if I have got factorial 5, okay, then I can write 5 into factorial 4. Okay, factorial 3 I have, then I can write 3 into factorial 2. If I've got factorial 2, then I can write 2 into factorial 1. Yes. So factorial 1 can be written 1 into factorial 0. Okay. And here I have taken few examples. In fact, I have solved it. So one is factorial 8 upon factorial 4 into factorial 3. So what we can do is factorial 8 can be written into as 8 into 7 into 6 into 5 into factorial 4. Why I left factorial 4 here? So that in denominator, okay, this to get numerator and this denominator can get cancelled. Okay, that's why I have written 8 into 7 into 6 into 5 into factorial 4. Okay, and down I have factorial 4 into factorial 3. So this factorial 4 and this factorial 4 cancel. So I'm left with 8 into 7 into 6 into 5, and down factorial 3 means 3 into 2 into 1. Okay, after that whatever you can cancel, you will get 280. Okay, here factorial 30 upon factorial 28. Okay, so you get this 30 into 28 into factorial 28 factorial 28 upon this factorial 28, cancel. So you're left with 30 into 29, that comes 870. Okay, this question is you have to find the LCM of factorial 4, factorial 5, factorial 6. So first you should find that what would be factorial 4. Okay, so factorial 4 will be this 4 into 3 into 2 into 1. Okay, here you can see that this 4 can be written as 2 square. Okay, so you got 2 cube into 3. Factorial 5 can be written as 5 into 4 into 3 into 2 into 1. So that means I can write 5 into 3 into 2 cube. Okay, because here 4 can be written 2 square, here is 2 to the power 1, so 2 cube. Factorial 6 can be written as 6 into 5 into 4 into 3 into 2 into 1. So you get 5 into 2 to the power 4 into 3 to the power 2. Now we are looking for LCM. So what you do? In first you have got 2 cube. Here also you have got 2 cube. Here you have got 2 to the power 4. So take the one which has got maximum power. So we'll write 2 to the power 4. Then here we have got 3. Here we have got 3. Here we have got 3. So take the one which has got maximum power. So we get 3 to the power 2. Then into. Now here we had 2 and 3. So already 2 and 3 mentioned over here. Here we had 5, 3, 2, out of which 3 and 2 already we have taken. Here we had 5, 2, 3. So out of these 3, 2 and 3 mentioned. Here 5 is left. Okay. And here also 5 is left. Which one is of maximum power? Both are same. Yes. So 5 is written over here. Then you get the LCM. Okay. You'll have done in class 4 this type of things. Okay. When you have to find the LCM by prime factorization. Okay, this question is convert the following products into factorials. Okay, so we have got this. Okay, 6 into 7 into 8 into 9. This is 2 into 4 into 6 into 8 into 10. We have to write in factorials. So see over here, you know that here if I have got factorial 6, then you have to take 6, then you have to decrease by 1 and you have to do till 1. Yes or no? But here I have got 9, 8, 7, 6. I cannot write 9. You cannot write factorial 9 because here 5 is not there, 4 is not there, 3 is not there, 2 is not there, 1 is not there. Yes or no? So this 6 into 7 into 8 into 9 can be written 9 into 7 into 6. Okay. Then what are missing over here? 5 into 4 into 3 into 2 into 1 is missing. Yes, that means what is missing? Factorial 5 is missing. Yes, so I will multiply and divide by factorial 5. Yes, so factorial 5 multiplied and divided by factorial 5. So now if you see over here, 9 into 8 into 7 into 6 into factorial 5. This is nothing but this is 9 factorial 9. Yes, and down we have factorial 5. So that's how we have been able to write this product in factorials. Okay, now we have got 2 into 4 into 6 into 8 into 10. Okay, so you can see that in each term, okay, 2 is common. Yes, so 2 5s are, 2 4s are, 2 3s are, 2 2s are, 2 1s are. So 2 can be taken out as common. Okay, so here from here you get 1 2, from here, so altogether how many 2s you are getting? 5. So 2 to the power 5, and you are left with 5 into 4 into 3 into 2 into 1. But this is nothing but factorial 5. So it's 2 to the power 5 into factorial 5. So you got the answer. Next, find n if. You have to find the value of n if factorial n plus 1 is equal to 12 into factorial n minus 1. Okay, you have to find the value of n if you have got this. Same for this also. 1 upon factorial 9 plus 1 upon factorial 10 equal to n upon factorial 11. So let us start with the number 1. So here factorial n plus 1 is equal to 12 times factorial n minus 1. So you can see over here this n factorial n plus 1 can be written as n plus 1 into, from here you have to reduce by 1, so you'll get n. Then from here you have to reduce 1, so you get n minus 1. Okay, so you get n plus 1 into n. Okay, in fact I should have put this in bracket first. Okay, when you are copying this, please put this in bracket. Okay, then in bracket you have to write factorial n minus 1. Okay, equal to 12 times n minus factorial n minus 1. Now what will happen? This factorial n minus 1 and factorial n minus 1 on the right, they will get cancelled. So you are left with n plus 1 into n equal to 12. Okay, now simplify it. You'll get a quadratic equation n square plus n minus 12 equal to 0. Then do the factorization. You get n minus 3 into n plus 4 equal to 0. So you get n minus 3 is equal to 0, n plus 4 equal to 0. Then you get n equal to 3 and n equal to minus 4. Yes. So we can take the positive, we cannot take the negative, because factorial is defined for only positive integers. Okay, and this is minus 4. So rejected, since n cannot be negative. Okay. Next, this 1 upon factorial 9 plus 1 upon 10 factorial 10 equal to n upon factorial 11. So here what we can do is 1 upon factorial 9 plus this factorial 10 can be written as 1 upon 10 into factorial 9 is equal to n upon this factorial 11 can be written as 11 into 10 into factorial 9. So factorial 9 here cancelled, here cancelled, here cancelled. So I'm left with 1 plus 1 upon 10 equal to n upon 11 into 10. Okay, simplify, you get, when you take LCM over here, you will get 11 upon 10 equal to n upon 11 into 10. Okay, cross multiply. Okay, this 10 and this 10 cancel, cross multiply, you'll get n equal to 121. Okay, that's how you get your n. Okay, now next thing is, for the next chapter, binomial theorem, we will need to know what is this, what is the value of this NCR. Okay, here C stands for combination. Okay, C stands for combination. We have got a separate chapter on this. Okay, permutation and combinations, that we'll see later on. Okay, and for this chapter binomial theorem, we only need to know the value of this NCR. Okay, so we'll see what, if it's written NCR, then what is the value of this NCR. So here value of NCR, or you sometime instead of writing NCR, they write capital letter C. Okay, and then in bracket they'll write n comma r. Okay, or sometimes they'll write, okay, in this bracket you'll write n and here r. So these three, okay, these three mean same. Okay, so most of the time we use this only, NCR. Okay, or this. Anyway, I've written all these three, so whichever you get, you should not be confused with. Okay, so NCR means, NCR is equal to factorial n upon factorial r into factorial n minus r. Okay, so suppose in place of n I have got 4 and in place of r I have got 2. Okay, 4 and 2, then it will be factorial 4, factorial 2, and 4 minus 2 factorial. Okay, factorial 2, 4 minus 2. So, and you should always remember that here for NCR, r is positive integer. Okay, it is from greater than equal to 0. Okay, r is always greater than equal to 0, and n is greater than equal to r. Okay, so NCR is defined only when n and r are integers such that n is greater than equal to r. Okay, where and n is greater than 0. Okay, so n is greater than 0 and n could be equal to r. Okay, and r is greater than equal to 0. Done. So n is always greater than 0, you should remember. Okay, like here, if this is n is 4, then r is 4. Okay, but here we cannot have 0 0. Okay, we cannot have 0 0. We can have 4 over here, then 4 3 3 1 1. Okay, like that. So such that r greater than equal to n greater than equal to r, n greater than 0, and r greater than equal to 0. You should remember this. And number 2, this is important. Okay, that NCR is equal to NCn minus r. Okay, where r is greater than equal to 0 and less than equal to n. Okay, so if I take r to be 0, okay, then NC0 will be equal to NCn. Okay, like here, for example, if I take n to be 4 and r to be 1, then 4C1, okay, you will get 4, and 4C4 minus 1, again you will get 4. Okay, and this third, if NCP is equal to NCQ, okay, NCP is equal to NCQ, and then either P is equal to Q or sum of P and Q is equal to N. So if you have something like this, NCP is equal to NCQ, okay, then either P is equal to Q or P plus Q is equal to N. Okay, so from here we can conclude that if we have got NCP is equal to NCQ and P is not equal to Q, then in that case P plus Q will be N. Okay, you can see these examples here. NC18 is equal to NC12. NC18 is equal to NC12. So here you can see in place of P what we have 18, in place of Q we have 12. Clearly 18 and 12 are not equal. So in that case what will happen? 18 plus 12 will be equal to N. 18 plus 12 will be equal to N. So if NC18 is equal to NC12, then find the value of 32 Cn. Okay, so I have to find the value of N. So how to find the value of N? From this property you can find the value of N. Here you can say P is 18, Q is 12. They are not equal. That means 12 plus 18 will be equal to N. So given NC18 is equal to NC12, clearly 18 is not equal to 12. Then N is equal to 18 plus 12, that is 30. Okay, then 32 Cn will be 32C30. After that apply the formula, okay, NCR formula over here, and you will get 496. Okay, so this we did just before starting the new chapter, binomial theorem, because we will require to know this factorial and NCR. Okay, so here no homework for you, you just need to copy it and understand the concept of this factorial. Okay, so this is all for today.